Okay, this is video number 2. We have purchased a Little Giant power hammer that is missing the original clutch, which Brian's going to point to right there. You can see that. That's a cast iron one. It was made from the factory, and we're going to fabricate one out of steel and welding and so forth. And I'm going to show you what that clutch looks like here. It's got several components to it. The first thing we're going to look at is called the spider, which he's pointing at right here on the inside of that diameter. It has wooden blocks, and this will engage in the friction plate, which he's showing you right there. That's a friction plate which will engage into the wood. As you step on the treadle, it'll push that into those woods and engage the main shaft, which is pinned. You can show you the little pin. That's pinned to the main shaft, which stays stationary. And the main pulley assembly, which is all this you see here, the belts are riding on, that spins continuously on a Babbitt surface. And when you engage it, it'll drive forward. And here's another view of the back of the clutch. That's the backing plate that he's showing you there. And also that is the clutch arm that's going to push that forward and back and forth, that rides on that, what do you call that, Byron?
Spider.
Spider, rides on the spider, correct. Okay, we're going to show you some parts and pieces that you would need to fabricate one of these at home. And what we're going to start with is the spider, which is what you see right there he's pointing at with the wooden blocks. And what we started out with was a 6x6 3/4 inch thick steel plate, and that has a 3.5 inch hole. Is that correct? Or a 3 inch hole in the middle, excuse me. A 3 inch hole in the middle. And he has drawn up a template for this that we will cut out of this plate here. Let me see if I can see his drawing a little clearer. It's not really showing it that well. You can see it somewhat. This will get cut out with a pair of scissors and laid onto that plate, and we'll torch cut that. And that'll be most part of the spider. You can see some of the dimensions.
Let me set this piece.
He'll set that piece on there. It's not really showing real well with the pencil. Yeah, I'll set it on there like that, and we'll trace that out with a piece of soapstone and cut it out. You got the different curves to it. You can see the hole in the center. That's the way that will go right inside there. And that 3 inch will set inside like that. That'll get ground welded into place. And that's pretty much the pieces for the spider. We also have pieces.
Here's another side view.
Yeah, here's another side view of what the spider looks like. You can see that's the shaft. This is the spider that we just talked about. That's a 3/4 inch plate. And those little tabs that you see right there he's pointing at, that's going to be the angle line that you see right here. That's 2x2 angle line. He's got some marks already on there. I think they're like 6 inches, and we'll turn up the ends so that block of wood will be stable.
Where is that? Oh, on the template.
Oh, right on the template, yeah. Okay. That what you see right there, that's where the angle line will be attached. We'll weld that on. And once again, those are the angle will be hooked right there, and those blocks of wood will be bolted. And those are adjustable up and down as they wear inside that friction plate. Okay, going on to what the wood is. What we have here is we have a piece of beech, and that's what they recommend for those friction blocks, would be beech, and that gets slightly oiled so that it slips and rides inside that friction plate. And this is what we have for the friction plate right here. It's a 12 inch outside diameter and a 10 inch inside diameter, and we're approximately 3 inches deep with that piece there. So that's how thick it is.
The inside of that friction plate is going to be machined on a taper right here, that taper also gets machined on the wooden blocks in the spider, which these wooden blocks would be right in this location after assembly. So when the operation of the machine, when the friction plate is moved axially, it will engage the taper on the friction plate to the taper on the wooden blocks, transferring the power to the main shaft where the friction plate is fastened onto the main shaft through keyways.
Very good. And this will all, and then moving on here a little bit, we have the backing plate over here, which is 14.5 with a 4.5-inch hole in the middle, and that's a 1-inch plate. And those shafts ride on the inside, which you see right there. That's the backing plate that he's showing you right there.
This piece be welded on.
Would be welded on. And then we have the 14 by 13. That's 14 outside diameter, 13 on the inside, and that's what the belts will ride on. That also gets welded to the backing plate right onto the outside. We'll also do a quick just an assembly so you get a rough idea of how this stuff's all going to go, and we'll obviously do step by step as we go.
This piece here.
That piece there is what we consider the clutch collar, is that correct?
The hub.
The hub.
Yeah, the hub of the clutch collar.
Yeah, that gets welded to it all. That will slide back and forth on a babbitt, which he's going to assemble, show you roughly what this is all going to look like. This piece will slip over the top. The big piece is going to, and in between these two pieces, we'll have babbitt material. Right in there, right where he's showing you, that'll get filled up with babbitt material. And what we do is we put in a dummy shaft, which is a little bigger than the original shaft that's going in it, which would be that one. And that'll be in the, this one will stay pretty much the original size, and then he'll turn down the one that's going to be welded in there is going to be down to 10 to 14 thousandths smaller than this shaft here. That way we have a little clearance between the shaft and the babbitt, so it will ride smoothly and turn nicely on that. And anything else, Byron? You want to do a quick assembly?
Yep.
He's going to do a quick assembly just so you see where all these parts go in relative to each other. That is the beginnings of the spider. That will go in there. Of course, we have some little cleaning up to do so everything fits just right. These were all bought at Lane Supply as a rough material, and they'll get machined. Byron has a machine shop here. He will machine all this stuff. This is the friction plate he's adding in there right now. And that's where the belts will ride on that. Right there. Pretty cool looking stuff. And it'll be neat to see this all come together. Of course, this is going to be all welded and ground and milled to work properly, unlike the original ones, which was all cast, and those are unavailable at this time. So we had to make our own, and we'll go through the steps and see how it all works when it's all put on the machine. Hopefully we'll all be happy. Alright, we're down to Byron's machine shop, and we're going to be working on the spider. He's going to cut some slotted holes in this here. If you look at this piece, you see right here the drawing. See the slotted holes we have in that right there. He is going to mill some holes in this right here. I'm going to bring it up a little closer so you can see it work. Okay, we'll be quiet for a minute while this is doing this job. Excuse me if I'm a little shaky. Just got to keep plenty of lubricant on this so it don't burn up his bit.
In 2 passes. I'm making a shallow cut To start with, I'm going to mill from one slot to the second hole that I have already prepared. And then I'll plunge down through the rest of the thickness and finish the slot. I'm going from one access hole like these to milling this section out through the middle, as well as taking it to finish width.
These holes that he's milling now will retain the wooden blocks in position as they're bolted to this spider, which is called a spider. And we'll show you some of the other components here shortly with it. As in the first video, we showed you a 6x6 square plate with a 3.5-inch hole in the middle, and the 2x2 angle iron has been welded on to that block. Plus we torch cut the shape of that spider up with a torch and then ground and shaped it. Building one of these clutches is a lengthy process because there's a lot of precise work involved. As you see when Byron starts explaining the main shaft, dummy bearing, and the bearings that will be used adjacent to the babbitt material. Once again, got to use lots of lubricant. These bits are really expensive, you don't want to burn them out.
I'm almost at the end of the cut on this side. As soon as I start touching that, I'm going to give it like about another 20 thousandths, 25 thousandths. You'll hear the load change on the cutter. Complete that. I previously measured the width, so I knew when I hit the back of that slot how far I'd have to go. Now I'm going to go back over to the first side, and I'm going to pick up the wall on that edge, which is just about right there, and we're going to give that 25 thousandths additional. Back away a little bit. Remove the cutter from the cut. And we have our finished slot.
And a nice looking slot it is.
And we have to continue this process for these slots over here, which will complete these slots here, so we'll have those 4 slots. As Jerry commented, we have those slots will be represented holding the wooden blocks into that spider after assembly. These are the bolt holes that we are making these slots for right now. The elongated slot is going to allow us, as the blocks wear down during operation of the machine, we can put shims underneath the block to shim that width out, which will allow us to continue using those same blocks as the dimension changes for the fit up between the pulley and the spider. Okay?
Very good.
Now, after we complete this, the next function on completing the spider is going to be to weld the bearing that we have prepared,
Let me get that
which is this section right here. Now on the original manufacturing of this clutch assembly from Little Giant, this was a cast iron assembly. Now that is not available, so we're going to take and we're going to try to replicate that original clutch design based on a fabrication. So this is going to get welded into the bore, and that will complete this assembly. We got some lubrication holes that we're going to have to do, but those are going to be incidental compared to the whole manufacture of the Spider. Now, during assembly, for the finished pulley to run on this bearing surface, there has to be a clearance between the coupling, not the coupling, but the pulley, to provide lubrication room from this finished bearing. Where this product uses a Babbitt bearing, what we have to do is provide a dummy bearing that is 10 to 15 thousandths larger in diameter than what the finish is. When we pour the Babbitt later on in this process, that will, using the dummy bearing that is 10 to 15 thousandths larger than this, once that's disassembled, we can put that piece over this and we have the provided clearance that we need for lubrication. That process is over here in the lathe now. I've got the dummy bearing in the machine. I've got it rough polished. It is now 10 thousandths larger in size than our finished bearing, which is the minimum clearance that we need. But because we're going to do such a nice job with this process, that amount of clearance is going to be really nice. This thing is going to run great. I need to find...
Recording.
All right, I've rough polished the bearing with a 220 grit paper. I've now got a 320, and I'm just going to give it another little light polishing. And my speed tripped.
He's going to try this again.
And here we go. Alright. So what I'm going to do now is I'm going to take some 320 grit paper and just give it the final finishing. We have a nice smooth surface on there now, and that's going to provide a very nice finish on our Babbitt after pouring that. The Babbitt is going to go inside this piece of mechanical tubing that we have here. It hasn't been prepared yet for the pouring, but at a later date we'll have an update on the video showing how we're going to prepare this and then get it set up for pouring the Babbitt.
You show him the original, what's going to go right inside that, Myron? Your other shaft here? It's going to go inside what he's showing you here. Just show him how that's going to go in there. Yep.
After the Babbitt is poured in this piece from the dummy bearing, that is going to ride over the top of our finished bearing, and that void that you see between these two parts right now will be filled up with the Babbitt material. That's how that's going to run. We're going to have a lubrication point on the end of this shaft, and we're going to have a lubrication point coming through this piece of the pulley, and we'll be able to, with our grease zert fitting, which will allow us to introduce the grease for that to ride on.
Hope you're all following this.
There's a lot of work left to do. This has got to be all mounted in here this piece has got to be machined. We have a lot of fabrication work left to go. But we're nearing the completion of the spider.
Very good. I hope you guys all got this. Once we set up to turn the friction plate, I think that's your next project, isn't it, Byron? The friction plate? Or
Well, I've either got to take and turn this friction plate, or we've got to prepare the base plate for this whole assembly. This bore has got to be machined large enough to accept this piece to go into it.
very good. We'll see you shortly on the next process.
See you next time.
Alright, we're set up today to weld the spider bearing to the spider assembly. As you can see, we have 2 tacks here. We've got it squared up, and we're going to apply a couple more tacks and keep checking the squareness to make sure that when we put this on the lathe that it's going to spin true. We just want to show you how we're all set up here. The shaft hangs down 1/8 of an inch on the other side, so we have 1/8 inch shims underneath this to pick the spider gear up and allow the shaft to drop down onto the steel plate, which will give us our 1/8 inch exposed on the other side of that plate. And we're going to do a couple more tacks here, and we'll come back and show you what that's going to look like when it's finished tacked up and squared, and put it on the lathe, make sure it's true, and then we'll do some solid welds. Okay, we got this thing pretty square with the gear on the end of it. Byron's going to do a couple more tacks on here. Watch your eyes on the video here. I'm not sure how this is all going to come out. There, just got another nice tack on there. That is a MIG welder, 220 volt. Got nice penetration around that. We've done a weld prep on our piece, and we're slowly filling it in around now and checking our squareness as we go to make sure that this thing isn't walking out of shape. This could be spinning, so it needs to be really precise.
It's almost done.
Okay, this piece is almost done. We're going to slide it on the main shaft of the little giant here. Look at that, it's sliding right on, all the way right to the end. And that is our spider gear. That seems to be running really smooth. Byron says we have about 2 to 3 thousandths play in that shaft there to allow that to ride nice. You see out in the end here.
I'm going to rotate this so that we can see.
He's going to rotate the...
So you can see the keyway.
I'm going to show you the keyway. Let me zoom in here a little bit. Yeah, right there. You can see the keyway. And that shaft will get pinned to the main shaft, the bearing shaft, which is Byron's got his hand on right there. That'll be slid all the way on, and that'll get keyed to that main shaft, and that'll stay stationary on that main shaft. And then our babbitt will be surrounding what he's grabbing right there with another 4.5 inch pipe on the outside of that, and that's what everything will be riding on that shaft right there, and that'll be spinning constantly, running from our motor down here. Right, there's our pulleys to the motor, and those belts will be coming up onto that 14 inch round plate that you see earlier. So far
Still
so
waiting
good.
to be built.
So yeah, still need to be built, but we're coming. Those are those slots that you see there that we looked at yesterday when Byron was milling those out. That's where our wood blocks will go, as you've seen on the picture, right in that area. So we are slowly coming. Byron still has a lot of mill work to do on that, lathe work I mean, on the friction plate. That's going to be time-consuming piece. And there you go. We'll get back to you as soon as we take another step forward.
One. Okay, we've got the friction disc has been cut to length. The OD has been done on it. But when I came to start doing the inside to do that taper, then my boring bar that I had was not going to be adequate to do that job. So I've ordered a new boring bar, and we've left that job for the time being. So now we're going to move over and we're going to start working on the big plate. There's a large plate here that's going to hold all of these pieces together on the pulley. Now I've got that mounted up on the milling machine. I've got it set up and I've started boring out the center of it. This hole in the center has got to be large enough to fit this pipe into, and then at some point this will get welded inside that plate. This is going to become the bearing surface. So I'm in the process of working on boring it out, and we'll start the machine, and it gets kind of noisy. I have to do this by hand because I don't have a power feed on it. And that completes the passion. We've got to do that a whole bunch more times to open it up, because when I ordered the disc, I didn't order it with the burnout hole in the center quite large enough so that I would only had a few cuts in order to bring that into size. So that's allowed me to have to cut about a ½ inch on diameter out of this bore, which, as you can see with a fairly fragile tooling setup, is going to take quite some time. So that's what I'm going to be working on today. Well, we've finished the boring of the big plate, and we have fitted the hub into it, and that's where that's going to stay. That's going to be welded in permanently here after a while. For now, we have that piece complete and ready for moving on to the next pieces. We'll be back to you later. All right.
Thank you.
Today we've got the spider set up on the mill, and we're drilling a hole down through this body of the bearing area, which we're going to provide a grease fitting here on this end. I'm going to drill down in there, and I've got these extended length aircraft drills in here. I've got two different sizes. I'm using a 1/8 and then following it with a 3/16 diameter and working my way down, kind of pecking my way for a real deep hole. I'm going to be drilling down to about in here, approximately around 3.5 inches down into the body of it. And then I'm going to drill a radial hole in to intersect that. That's going to allow, after we put the grease fitting into this section, it's going to allow us to be able to grease the bearing in two locations. One's going to be on this fitting, and the other one is going to be on the clutch pulley itself. So what we're doing right now is just working our way down with this small hole. And I've already already got this piloted down in there, gone down quite a ways. I just switched over from the small drills to the extended length drills. And we're going to hit, there's the bottom of the hole right there. I'm going to set my 0. I've gone down pretty close to 5/16 there now. Now I'm going to return, pick that up out. Clean the chips out, lube it again. And I'm going to go back down, and I'm going about a 1/2 inch at a time, and then switching to the larger drill and working my way down to avoid possibly breaking the drill, which would be a real problem. I'm trying to be very gentle, not forcing the drill, keeping the chips cleaned out of the hole so that it doesn't pack around the drill body, which is what will lead to drill breakage. And there we are on the bottom. Gone a 1/2 inch from where the bottom of the hole was previously. So now we're going to take that drill out. We'll put in the 3/16 drill bit, and we'll follow this hole down to the bottom, and then we'll go back to the 1/8 inch again. And we'll continue that process until we get down in there about 3.5 inches. I can feel right there that I'm picking up the bottom of the previous hole, and I reset my 0. And we're opening up that 1/8 hole to the 3/16. Again, I'm going to retract it out of the hole, clear the chips, lube it, and back again. Right there, I can feel it. I picked up the other hole. And I'm just approaching the bottom right there. I can feel the bottom of the hole. And I'm going to continue this process until we reach about 3.5 inches in depth, which is going to put us down in about this area down in here. All right, that's it for today. Well, good morning. We've completed drilling the grease hole in the end, and we've set up and tapped the hole about 1/4 inch deep for a 1/4 inch zert fitting. That's going to allow us to grease the bearing from that end of the shaft. We've got to still drill a cross hole through the body of the spider and intersect the bottom of that hole about 3.5 inches down into the wall of that tubing. And we'll show you some pictures of that when we get set up and start moving along in that direction. And until next time, we'll see ya. Okay, we're back with the spider. We've completed installing the grease zert fitting and drilling the cross hole. You can see where the grease is going to come out to supply the bearing with grease. Well, that completes the spider manufacturing, except for in this area here we're going to have to make the beach blocks, which will be the contact surface. Other than that, this piece is going to be complete. Alright, we'll see you in a little while with the next project. Ready? Okay, today we've got the new boring bar that we needed in order to machine the 5-degree angle in the friction disc. So we've got that set up now, and we're going to start machining that. So I've got to take a whole lot of material out of this, and I'm going to do it all by hand, because I don't have power feed on this slide. So this is going to take a while, but this is what we got to do in order to machine that surface. So we'll get back to you in a little while when we've made some more progress. But as you can see, this is going to take a while. Alright, we got the new boring bar. We're machining the inside of the friction plate now. Cutting the 5-degree taper. We have the compound on the machine swung at 5 degrees, and we're feeding down across. As you can see, we're opening that up, cutting the taper on the inside there. I have to do it by hand because this machine does not have a power control on this compound. I power feed in and out this way, but I can't on an angle like that. So we're working away at it slowly by hand, and that's what it looks like. We got a ways to go. We're making progress.
Let me see if I can zoom in and get a shot of working his way in on that taper on the friction plate. You see it taking a little bit off at a time.
Well, we've got this side of the taper completed, and we're going to have to take and reverse the part in the chuck so that we can cut that section that you can see that didn't get done, because that's what we're chucking on. And because the lathe is small enough so that I can't chuck on the OD, I have to check it on the ID. So I'm going to have to turn it around and rechuck the part and then make a blend in the middle following that same taper. So we'll pick it up next time after reversing the part, and we'll start boring it from the other side. See you later. Alright, this morning we've taken the friction plate and we've indexed it around and reversed it in the chuck, and had difficulty getting that chucked up because we have to chuck now on the taper, and it doesn't give us an awful lot of contact surface, so we've got kind of a fragile setup. So now we've got a little bit of material. We get down in here, you can see the amount of material that we still got to cut off because we wasn't able to machine all the way through in one pass, which would have been ideal, but we needed a larger lathe in order to do that. So I'm pretty much ready to go. Now I've got the tool set, and we're going to start machining the rest of that, and hopefully it won't come dislodged from the chuck, which will be a disaster if that happens. So we'll see you in a little while. Well, there we have it. We finished up the friction collar, and as you can see, we got a blend inside. There's a little small step in there. I'm going to take some Scotch-Brite and blend those surfaces out and get it all nice and pretty. So that completes that part, and probably that's going to be about it for today. Other than cleaning up the machine, I've got a real mess. Alright, see you next time.
Okay, we're getting ready. We're drilling some holes in the pulley hub. This is what the babbitt will be poured inside this thing, and what these little holes are here is we'll weld the very outside where he's entering with the bit and leave that hollow hole on the inside, and that babbitt, when it's poured, it will go into those, keeping that babbitt from turning on the shaft. And what he's doing there, and he's got roughly 6 holes drilled into that, as you can see right there. And we'll drop a little 3/8 plug in there short of the inside diameter and weld the outside, smooth them up, and that'll leave those little round holes on the inside, as you can see in there. We'll clean little burrs up on those, of course, but that babbitt will flow up through there and go into those little holes and keep that babbitt from spinning on the main shaft. Okay, here we are. We got some more pieces manufactured here. What you're looking at here is a clutch collar. This will end up getting cut in half here, the whole thing will be, and these will get bolts through here, and this is where the clutch forks will grab a hold of this clutch. This moves back and forth on this clutch hub you see right here. This will end up getting milled out, and this will end up sliding down over the clutch hub and have some retainers that hold that clutch collar in place. That's what we're going to do today. We're going to do some wraps around here with some 1/2-inch square stock, 2 pieces around, and then this clutch collar will set and bolt in between those 2 pieces of 1/2-inch square stock. And what's going to happen is the clutch hub will go into this plate we have here. Byron has milled this out so this fits in there, and then we have the spider gear, which is this here. We've manufactured this. This is all ready to go. This will end up going inside that clutch hub just like that, and that little space that you see in there Byron is pointing to, this will get filled with babbitt material, and that'll be the bearing surface that this thing spins on. And we'll show you the process here as we go to this. We're kind of anxious ourselves to pour the babbitt material. And what Byron has here is the spider friction plate. He has milled this out with a taper. The inside of this is tapered, thinner here, thicker down here, so when it rides on these wooden blocks it'll engage right in there. As you can see, we got quite the thing going here. And this is the outer ring which the belts will ride on that big plate. I know it looks kind of confusing at the moment, but once we get everything done, get all put together, you'll see how it works, and we're hoping it works good too, because this is our first clutch we ever made, probably our last, but but there it is. We'll keep you updated as we move along. Okay, we're wrapping this 1/2-inch square stock around that clutch hub, heating it up and using the C-clamp to hold us close and tight to it. We're going to do 2 wraps around this thing. This is going to be the first wrap. It's a slow process, just heat and slowly wrap it around this pipe, and that'll be creating a retainer for our clutch collar. And I will shut my camera off here in a second.
It's going to form a groove.
It's going to form a groove, yeah. There'll be 2 pieces going around, and that clutch collar will set in between.
Roughly a 3/4 inch gap between the two rings.
Alright, I'll shut my camera off and we'll turn it back on shortly here and show you what's going on. And here we go. We got the first wrap around. As you see, we're good and tight all the way around this. We've left a little gap here so that we could fill the rest of that in with weld. That way we could get our wrap up nice and tight and not touch our tack weld on the beginning of the wrap there. As you can see, there's a tack weld there. We want it to be a little short so we get up snug tight to that collar. So we're going to take it outside and we're going to tack weld this in. Then we're going to start our second wrap, which will be in this area. I'm try to put my finger up here without touching it because it's pretty hot. Well, I guess you can't see it. There we go. Right in that area there someplace, just below that, about 5/8 of an inch. We'll be right down in there, 3/4. And that's what it looks like. Here we are, we got the first wrap on there and welded. We've got some 5/8 spaces around here, and we're going to wrap this piece around up to those spaces. Then those spaces will be just ground off and tapped right out of there. And all that what you see there looks a little rough. That'll get all milled out with a lathe and look really pretty when it's all done, which you'll see here shortly. Of course, it's going to take us a little longer than what you're going to see it, but there's a rod. We're ready to heat up and bend. There, we got our second wrap on there. As you can see, we have multiple clamps holding everything into place. And what we're going to do next is take this outside and we're going to weld this, if I can show that joint to you. Yeah, the joint's like right in there. That's where we'll weld that up, and then right by each one of these clamps we'll put a tack weld to hold everything in position, and that should give us 5/8 of an inch between those two bands. And our clutch collar is 3/4 of an inch, so Byron will mill this down, giving us a few thousandths clearance for that clutch collar to spin in there, because this piece we're looking at right now will be that's not spinning right now. That piece is stable.
No, piece is stationary.
That piece is stable, and that's what pushes back and forth on the clutch, pushing the friction plate into the wooden blocks on the spider. So we're going to take this outside and do some tack welds and weld that last band on solid. And we'll see what it looks like in a minute. Byron welding up the outer ring. Once we get this all welded, we'll knock those blocks out and take a look at what we got done. Well, here we go. We got the two wraps all done around there. We still need to get into this area in here, which will get trued up to fit this the clutch collar here, which is 3/4 of an inch, and we are 5/8 in between those two wraps. And Byron will set that in the lathe and turn that to be just a little bit bigger than the 3/4, so we have a little slop in there. And he'll clean that all up, true everything up. Those welds will get cleaned off with a milling tool as he does it, so you don't see all that. And this will look like a machine piece when he's all done with it. And it'll be really interesting to see what it looks like after this point. So next video we'll have this cleaned up and you'll see what it's going to look like. Anything else you'd like to add to that, Byron?
No, we're doing good. We're progressing well.
We're progressing well. So there it is. We will be back shortly and show you the finished product of that piece.
Well, here we are today. We've got the hub where we completed the welding of the 1/2-inch square stock on to form the groove where the clutch collar is going to ride. Now I've got to machine that groove to width and just kind of true it all up. I've turned a small wooden block to fit into the bore of that piece, and I'm about to take and center drill that, and then I can put the center in it to stabilize it. As you can see here in the chuck, we've only got a small area here that the chuck is actually grabbing on. So with the machining being done out on that outboard end, there's a risk of the part coming loose in the chuck and binding all up and causing lots of problems. So I'm gonna go ahead now and start machining that center, and then change out the chuck to a live center and install that, and I'll be able to go ahead and the part will be nice and stabilized. So we'll catch you in a few minutes and show you a little bit more. Alright, we've set up now and we're making a skim cut down on the inside of that first collar. And we're going to do the same type of process on the other side to the left of where that tool point is right now to establish a little over a 3/4 inch width to make room for the shifting collar. Alright, so you can see how that's working right now. And we'll pick it up in a few minutes with another cut. Okay, here we are. We're turning the OD on the second ring. And then we're going to get that down towards the same diameter as the first one on the right. Once we get that done, then we got to face the two sides and blend into the weld on the outside edges. You'll notice that there's no weld on the inside because that's where that shifting collar is going to ride. We don't want to have a weld down in that area. I guess we don't want to do it that deep a cut. We're going to back that off a little bit. Let's try that again. We'll leave a little bit for the finish pass. That's better. We're going to leave it right now. We'll catch it on another cut here in a few minutes. Alright, here we are. We're making a cut now on the second face to establish our 3/4 inch width. This pass I should be at 3/4. And I'm going to take and probably take another 30/2 of an inch off of that width on that side. That'll allow us a little clearance for the shifting collar there to ride. Alright, I got to back out right now as I'm doing the thing, and I don't want to run into the diameter down below. So I'll be back here in a minute. Alright, we're making the cut now on the back side of the second collar. We're almost down to size. I'm going to have to stop it right here and pay attention to the machine. And I guess we was doing some recording there. I got it, you probably had all kinds of things you was looking at. I've got that cut down now where both sides should be the same thickness. And we're going to leave it there for the moment. We've set up the clutch collar and we cut it in half on the over here on the power hacksaw. We cut it straight in half at the horizontal center line of it. And now we've brought it over to the milling machine and we're taking and go ahead and milling about 20 thousandths from the joint. We'll take that similar amount on the other half and then we'll have to drill for bolting those two halves together. So we'll leave you now. Choking a little here. Oh, you'll see how this is coming. we'll end up after we get it faced off. We're going to drill 2 holes for bolting the 2 halves together. We'll put threaded holes in one side and a bolt straight through hole, maybe countersink, on the other half, bolting them together. And that completes. Okay, this morning we're working on the second half of the shifting collar. We've milled the horizontal joint and have that done, and now we're in the process of drilling the bolt holes to secure the 2 pieces together. We've added a little bit of lubricant. We have a level set up on the piece to make sure that it doesn't move out of parallel during the drilling process. It's just giving me a guide to watch so that I don't get too much pressure on the drill and move the part. It should be secured pretty well in the vise, but you don't want to leave anything to chance. We completed the first half, and we tapped these holes. We used the tap drill size and tapped that out for 5/16 18 thread. I gotta take and clear the chips here. We're gonna continue this process and finish that hole, and that'll complete this side for this operation. And we'll see you next time.
They won't let me have a TV.
All right, we've completed that second hole that we left you with just a few minutes ago. I've now had the good old experience of putting the 2 pieces together and starting the Allen cap screws, and they both are threaded into the piece from one side to the other, and the alignment is good from side to side and end to end. I've minimized the clearance between the bolt hole and the threaded holes so that there's very little slop in there. That's going to help keep the 2 sides aligned. So I've got a little bit of work left to do here to dress these up, and then that'll complete the horizontal joint and the 2 parts mated together. The next phase, we'll have to go back to the lathe and machine the bore out, and I'm going to put an undercut in this surface right in here, and I'm going to put brazing material into that for a wear surface for when it gets assembled to the clutch itself, the clutch pulley, and so I won't have steel to steel working together. I'm going to have steel to the brass. So I'm hoping that that's going to work out well for longevity and minimize wear and galling. All right, that's how it looks at this time. We'll see you again in a little while. All right. Today we've got the shifting collar set up in the lathe. We've faced the 2 sides, and now we're boring it out to in order to fit the clutch collar. So we're working on that right now, boring that out. You can see we've got it almost cleaned. You can still see the little black spot going around. There's an area that hasn't cleaned in the bore yet. It's got, we've got about another 300 thousandths, 150 thousandths on the side. 300 on diameter to get out to reach our final diameter. Well, that's what this setup is looking like. Right here we've made an adjustment to take another 100 thousandths on diameter. We're going to engage the feed lever. Looks like this time we're going to get probably most of the burnout surface that Jerry, when he cut the parts out, looks like we still got an area that hasn't cleaned yet. But we're mostly there. Maybe on the next pass of 100 that we'll finish cutting out the burned out area from the torch. And we'll see you again in a little bit. Alright, we're getting it bored out. I just completed that second pass, and we still have a small area you can see down in the bore that hasn't cleaned. And we've still got a little over 1/4 of an inch of material to take out of the bore of the shifting collar. Now my process here is to cut that bore so that when it comes over here, where it has to fit is in that groove right there of the hub, which is actually going to be the pulley once that's welded in to the other plates and the friction collar and everything is all assembled. The collar that I'm machining in the lathe now goes into this, sits into this groove, and the clutch mechanism is actuated by a foot control. And that collar that we have over here, the shifting collar here in the lathe, as you can see, is a two-piece unit bolted together. And that will be, of course, separated in the bore here. Once I get done cutting it out to finish size, I'm going to put some brass, or my attempt to inlay some brass in that, along with a groove that I'm going to put in this surface on the face for a wear surface for on the shifting, not the shifting collar, but over on the clutch hub itself. So I'll put brass in there and then machine it to the final size. At least that's my my plan. We'll have to see how that all goes. If the brazing doesn't work well, then we'll have to go to a different type of plan and put maybe a phenolic material and attach it to the shifting collar here to take that wear. Alright, we'll see you in a little while. Well, since the last visit, I had the machining done on the shifting collar, and I had machined this groove in this surface here, this little undercut on the face. You can see it here, maybe a little better if I change the angle of it. You can see there's a small undercut in the face. And my intent was to put Teflon. I had ordered some Teflon sheet, and it's a 32nd thick. And I've got the recess in the face of the parts, a 32nd, and I was going to glue these with JB Weld onto the face of the parts. And then I was going to take these strips here and put each one in the bore. Those are the Teflon strips that I was going to use for the bearing surface on this part. Well, in the process of doing that, everything went well to the point where I put these pieces here in and doing on the face, and I did it on both halves. Let it cure for 24 hours. And then when I took it apart, after taking the clamps off, where I had it clamped down to this steel plate. Lo and behold, the JB Weld didn't fasten to the Teflon, and I had roughed up the surface of the Teflon to give it some bearing surface in order to grip the Teflon, but it did not work. I was able to peel the Teflon right straight out. So then I had to go back to the lathe, put these two parts together, bolt them up, put them back in the lathe, and machine out the JB Weld that had hardened, and then you have to machine it back off. So my wife then did some more investigating, and she found a similar Teflon piece of material, but it has a factory applied adhesive two-phase tape. It's 3M product. It is 3M 300, and it's supposed to bond that to virtually any surface. So now I have taken, and as you can see, I've cut some pieces off of here, and these are my new ones that I have made. You can see I've got you can still get the backing on it, and they're virtually a duplicate of the original ones that I've made. And I'm going to take and put those and try to fasten those on with the factory adhesive. According to the work instructions, this is a one-shot deal. You take and start the application by peeling part of the covering over the adhesive off and start applying the Teflon to the metal, and you better make sure that it is exactly where you want it, because they say it will not move, and if you do pull it off, you're gonna ruin that piece and you'll have to make another one. So I'm on that activity right now. I'm going to go ahead and I've got the pieces cut out and fitted, and I'm ready to give that a whirl. So we'll see how that goes, and perhaps this will be the answer to applying the Teflon. So we'll catch you in a little while after we've tried this and see what happens. Well, we're back here again. Where I left off the last time was we had cut out the pieces of the new Teflon that had the factory applied adhesive, and it was one of those peel and stick type applications. Oh, I have got those applied, and I've got the pieces clamped down to the steel plate. The instructions that I have here, they state, that after you get the material placed where you want it, lightly press it in place, and then you can, for best adhesion, you take and go ahead and apply clamps. It only takes, it says, a few minutes, but it also makes a statement that longer is better. So I'm going to go ahead and leave these on for several hours. Tomorrow is going to be raining again, so I'll leave these on overnight, and tomorrow I'll take and unclamp the parts, and I've still got to cut pieces that are similar to the ones that I had before that don't have any adhesive on them, and I'll cut out some new pieces from the new material and do the same application with them. My plan is that when I get those applied, in order to put pressure on the bore and hold those pieces in place, I'm going to go ahead and come over here and use where that part is actually going to fit. This is the hub of the clutch assembly once it's all fabricated up, and that shifting collar rides in this groove right here. So that diameter that's in here is slightly smaller than what the bore of the shifting collar is when assembled, including the thickness of the Teflon that once it's applied in there. So I'm going to go ahead and use the shifting, not the shifting collar, but the hub over here. I'm going to use that as like a jig in order to clamp those and force those pieces firmly into position on the shifting collar over here. That was a mouthful, I'm thinking, but that's what we're going to do. So hopefully this product is going to hold the Teflon firmly in place, and then we can move on. The next part of the application is going to be to take and start fabbing up all of these various components and doing the welding and pouring the bearings and so on. So we got quite a long ways to go yet. All right, well, we'll see you next time. Well, here we are back to work again. We've put the hub into the base plate and we're starting the welding process. The hub is located 1.5 inches into the main plate. I've got, actually it's 1 5/8 inches. So I've made some blocks. I put it on a steel plate on a rotating table and indicated everything in and tack welded it. Now I've moved out into the yard and I'm doing the final welds of the hub into the base plate. So that's what it looks like. You can see this is a bead that I've got, and I've got tacks going around on it. So I've got to finish that. After we've completed locating the hub into the main plate, the next step is going to have to set up for the temporary bearing. The bearing that is going to set inside of the hub that is 10 thousandths oversized to the finish bearing that's on the machine. That 10 thousandths larger diameter, once we press that piece out after pouring the babbitt, will give us the clearance that we need between the babbitt and the final bearing surface. That's going to be coming along, so I'll finish welding the hub in and we'll catch you next time. Well, good morning. We've taken this morning and we've set up, after welding, the base plate and the hub. You can see where the welds go all the way around the diameter of the hub, and have fashioned it securely to the base plate. Now this morning we're going to line up the dummy bearing. You can see the dial indicator now. We have that centered in the bore of the hub, and the next step here is going to have to be to take and fasten that dummy bearing. The dummy bearing being 10 thousandths larger in diameter than the finish bearing on the Spider. That's to allow for oil clearance when it's finally assembled. So we've got to take and secure that dummy bearing now in place. Not sure just how I'm going to do that yet, but that will secure that in place, and then we'll be ready to pour the babbitt down through the opening to line the hub with the babbitt material. So we'll get back to you here in a little while when I figure out just how I'm going to secure that in place. Some additional information on lining up these things. I have everything setting on top of a rotary table, and with this crank I can rotate the entire package on the top, and I've had to have that centered, and then when I set the dummy bearing in place, then I had to again indicate that in to make it central to the base assembly. Alright, I should have mentioned that on my first go-round, but didn't do that, so I'm just adding this information now. Thank you. Alright, I'm back. This is what I come up with for a harebrained idea to lock that dummy bearing in place. I welded 3 square nuts onto the hub, and then using bolts, I draw the bolts up against the dummy bearing. I've got a piece of brass as the contact point between the bolt and the dummy bearing, and the brass piece is held in place with a piece of tape in the event that I had to move something and I didn't want to lose the piece of brass down in the hole. So that's what it's looking like now, and I've done a run out check and everything is still good. I had to adjust it just a little bit from when I was tightening up the bolts to secure it in place. It moved a little, but I got it running now within about 4 thousandths. So I think that's going to be good. Next thing is we got to take and transport this whole thing up to Jerry's, where we're going to melt the babbitt and do the pouring. So I've asked Jerry to come down and take a look at this, where he's going to be instrumental in the pouring of the babbitt process, to see if he sees any issues on how I've got this set up. So right now I think we're going to be good. You can see how everything is all set here. I've currently got it sitting on top of the rotary table, but when it comes to actually pouring, we won't be doing that. We're going to have to set this whole thing down on a steel plate and then put putty around the base to act as a dam so that the babbitt won't run out underneath the fixture when we pour the material into the bearing area. Alrighty, so that's as I see it right now. We'll get back to you in a little bit.
What we're doing now is we're using the acetylene on the torch just to soot up this dummy bearing. What this will do is put a thin layer of soot on it, so that once we pull the babbitt bearing around it, it will not adhere to this dummy bearing, allowing us to get it out of the main shaft in there. That'll release from that babbitt bearing. You'll get that nice and black just using the acetylene, putting a nice black soot on it, as you can see. See if I can zoom in on that so you can see how nice and black that's getting. Oh yeah, that's turning nice and black. That'll act as a releasing agent. So we're prepping this and going to get ready to put the dummy shaft in there and get it all centered up. And in a moment we're going to start melting our babbitt material down, which we're using a 50-50 solder, which should be sufficient for the job.
We're hoping.
We're hoping, he says. I don't see why not. It's not far off from regular babbitt material, so perhaps even a little bit better. Has to be somewhat soft because it's high impact. And that's looking really good, Byron. She's blackening it up nicely. And we'll get back to you in just a few minutes when we start setting everything up, and we will videotape the pour. Okay, now we got the dummy shaft centering it back up into the hub assembly here. It's all sooted, getting it all centered nicely in there. As you can see, Byron's got those nuts and bolts here, which he'll center. Then he has his little, it's on a rotary table, which you see down here. And he's got his little gauge over here that he will he'll turn this and make sure he's true. That'll go right up against that dummy shaft. You'll get that all centered up nicely. We don't want to have to pour this and melt it back out and redo it because we rushed through it. Better off take your time, get it right the first time.
Town manager Derek Goodine on the job for about a year. One councillor who voted against the firing then resigned.
It's looking good.
Angus King says he will vote for President Obama's Iran nuclear deal. Congressman Bruce Poliquin
there we go. He's gonna do this up, and see, as you can see, he's turning it. He's watching his gauge, see how many thousandths we're off, and he'll adjust that with his little nut and screw sets.
reportedly exchanging artillery fire across their border. 3 dead and others wounded in
It's fussy, but that's not a bad thing.
outside a boys and girls club in
That's
Rochester.
about the low.
Former Subway pitchman Jared Fogle pleading guilty to child porn charges and having sex with minors.
Hey, what Byron's doing here is you can see that little worm type thing there. That's called Babbitt Right. What that'll do is make a dam underneath here. See, he's pushing that up against that outside of that shaft. So when we pour that Babbitt material, it won't leak all over the table. It'll contain it in the inside where we want it. He'll just get this around there, then he'll push it all up good and tight. We've got the table all leveled up. As you can see, he's pushing into his fingers. We'll work that around there in really good shape, creating a nice dam. And over here in the forge fire, as you can see, we have our 50-50 solder down inside here. We have some sticks in there. We're going to slowly melt this down. As you can see, fire's going good underneath that pot. This will melt this down. We want to get this up to about 450 degrees or so before we pour. That has to be up around 450. And also what he's doing over here, once his Babbitt material is in place, we need to take the torches and we need to heat this whole works up down here to roughly around that same temperature, so that when we pour the material in there, it adheres to the shaft, the outside of that shaft. And also what the heat does is takes any moisture out of that metal, because when you pour that hot stuff in there, where he's pointing his finger there, you don't want no moisture in there at all, because that'll spit and sputter and get all over everything and make a poor bearing. So we go. When we get ready here, we'll get this thing heated up, and we ain't far from pouring our Babbitt. This is our first pour. I've done a couple small bearings before, and this is mine and Byron's first pour. This is probably the biggest pour I've done and the most critical. So we'll see how this all goes, and we'll be back in just a second for the pour. Okay, what we're doing here is we're heating up this hub assembly here. Got 2 torches going on it. We're trying to get up to around 450 degrees. We have a thermo laser pointer here, or whatever they call that. What do they call that, Byron? A temperature reader.
Yeah, yeah.
You can see
Inside the bore, we're up to 229.
yeah, what we'll do is we'll get this probably close to 450, 475, and we'll let it set a little bit and soak, so that we're getting all the way through the center of the metal. Pretty thick steel.
It's a big heat sink, that ring.
Yeah, that ring is a big, suck the heat right out of it, so we're trying to get a nice even heat on this. Right now our Babbitt is almost up to temperature. As this thing gets hot, you'll see that it'll start turning blue and different colors, where this is pretty clean steel at the moment. We are starting to change color a little bit. When you get up to a good, almost to the temperature, you'll see the Babbitt right will start to smoke, which is under the table earlier. You saw Byron applying that to the bottom. Excuse me if I'm not getting a good picture here. I'm trying to run the torch and run the camera at the same time. But we'll get this hot in a few minutes. We'll be ready to try to pour that in there and see what we get.
Alright, we're recording.
We're good? Okay, what we're going to do now is we're going to add a little paraffin wax to this Babbitt material. What this will do, we throw it in there, that'll burst into flames in a minute, there you go. And we'll stir that around. What that'll do is bring the impurities to the surface, cleaning that Babbitt material up. What we'll do is let that go to the top, and I'll go along with this cold ladle, and I will skim all them impurities right off the surface. As you can see right on my thing there. See all that stuff's coming off top? You don't want that in your pour. We want this stuff to be up roughly around 600 degrees. And we're going to take a temperature reading now, see where we're at. We are going to be, I'm at almost 800 degrees right now, so we're going to let this, it fluctuates a little bit, 560. We're right in the range where we want to be before. Another way to check this too is you take a piece of wood, you stick it in there and count to 3. And if that scorches it, you're at a good temperature. So what we want to do is, safety is really important when it comes to this. I got a long sleeve shirt, I got gloves, I got my boots, but my pant legs are on the inside. We want to get those down over the top in case I spill it and don't run down the side of my boot. That'd be very bad.
This thing seems to be zoomed in, Jerry. How do I zoom it back out?
Right here, this one. Push that one way or the other.
That's better.
Yeah, we're at 500 degrees or so. That's right where it needs to be. Okay, let me gather everything up. We're going to pour this baby. Face shield, very important. I know I don't want to run through the rest of my life with a scarred up face. This is very heavy. We're going to pour this into this crack right here. You may get a little spill over, but you want to get this in one single pour. Slow and easy.
Running out all over the place. Get full?
No, we got a leak. Yeah, we have a leak. A Babbitt right leak. Son of a bitch. Well, that's what happens. We're gonna have to regroup here. Yep.
It didn't bond to the steel plate.
That's what it looks like. It didn't bond to the steel plate.
Too much rust on it.
Maybe too much rust.
Well, that's a shame.
Yeah, well, that happens.
Well, we're going to take and clean this mess up, and we'll have to start over again. We'll catch back to you in a little while.
Shit happens.
Well, we're going to try again and see if it'll... No, it's starting to leak. It's coming out.
Okay, we can redo it then.
Well, what we're going to try now, we've got a cast iron plate. It's a weight from a barbell set. Jerry's cleaning up the surface. What we think was a problem before was the rust on that plate that we were setting on. The Babbitt right didn't bond to it, plus that plate was fairly thin, so the heat, we think, kind of helped warp it, which broke our seal for the Babbitt right and caused the Babbitt to run out onto the plate. So now we're going to use this cast iron plate. We're going to clean the surface all up and go back to square one and try again. If at first you don't succeed, try again. Alright, we'll catch back up to you in a little while. Okay, here we go again. Jerry's cleaning the slag on the top of the Babbitt, and we're getting ready. They're going to make the pour again. Get over here. Jerry's got to suit up. Put on his heavy gloves.
Double eye protection.
Double eye protection.
If this doesn't work this time, we're going to have to let everything cool off, try it again in the morning. So I've noticed that when I put the Babbitt right on the bottom, it seemed to stick to the cold plate better than it did the hot, because we tried to re-put the Babbitt right on and trying to do it while it was still hot. But we're going to find out in just a minute if this is going to work this way or not. If not, we're going to have to try to do it in the morning and redo it. But worth a second try while everything is warm. Here goes.
Yep. Wish us luck. Wish us luck. Wish us luck. It sounds like it's getting full. So far, so good. Everything's holding.
Oh, coming up from the side. I don't know what's going on there, but is it leaking out the bottom anyway, Byron?
I don't see it coming out the bottom anywhere.
But she's pushing that stuff up right there. Okay, I'm going to go in a little bit more. Might be why they originally do a solid center shaft, because what some of that done is it pushed it up. I don't know, it could be just air pushing it up,
Right.
but give it a little bit more. Yeah, I mean, it looks good. At this point,
Well, a couple of things that we've learned is when you're going to pour the Babbitt, the base plate that we're setting on needs to be nice clean metal so that the Babbitt right will stick to it properly. The other thing that it looks like we have an issue with is it's migrated to into the dummy bearing on the bore side of it. So I think another time it would be better to have a solid shaft for the dummy bearing, or cap it in some fashion. If you only had a piece of mechanical tubing like what we did to use, we could put a plate on the bottom of it and weld it onto it, and then have that setting on the bottom.
Yep.
But you can see the Babbitt is reseated a little bit from the end of the tube here, but that's only about 1/4 of an inch right there.
I'm going to push down on this a little bit. Watch your eyes. That might be just air that we have in there. Is it coming up, or?
No, doesn't appear to be.
Okay, what I'm going to do is pour the rest of this in there, and I'm
Pour a
going
little
to heat
bit.
it with a torch.
Pour a little bit more. We're going to take and fill up that 1/4 of an inch there at the end.
And heat it with a torch. You will get a certain amount of shrinkage.
Yeah. This end is not an issue for the recession there a little bit. So what are you doing there now, Jerry?
What I'm doing here is just heating that surface of that babbitt material up. That should just make it flow in and leave a better, neater edge. There we go. Now if we can maintain that height, I'd say that's a decent pour. Which it seems to be staying there somewhat.
Good news is you can see our babbitt right. Totally nice and solid. The bond didn't break. We got no leakage there at all. We had put some babbitt right down in the bore of this pipe, which is our dummy bearing, and squashed it down onto the plate. But when we started pouring, either heat from underneath it or pushed that piece of babbitt right, which was about a little bit less than a tennis ball size, pushed it right up to the top of that pipe. But right now everything seems to be contained, and we're just going to kind of sit back and let it cool. The next step is going to have to be to clean up the surfaces here of it some, and then try to push that dummy bearing out of the hub assembly. That's going to be another experiment. All right, that's it for now. Whenever you're ready.
Okay, to recap on stuff that we have learned, so down the road if you tried this, you won't have to go through the mistakes we did. First of all, the first pour we did, as you saw, we had leakage in the babbitt right underneath here. But the main reason I think is the plate we had was a thin plate to start with, and it was rusty. We should have probably prepped that plate a little better and got a smoother surface for the babbitt right to adhere to. But also, I believe that plate was so thin that when we heated it, we had somewhat of a warpage, and when this plate does this, it kind of bows, it'll break that babbitt right seal on the bottom. And so what we've done this trip around is, while this thing was still warm, of course we were dizzy, we want it to work, so we went and rushed and got this dumbbell here. We cleaned it up, and we set our assembly back on here, and we put the babbitt right back in here while it was still warm. Probably not the best thing to do because you can get burnt, but we did it anyways. So basically, I think with this cast iron plate, we're not getting any warpage. We cleaned it real good, so we had really good adhesion to the cast iron plate and to the main shaft here that you see. And another issue we had when we're pouring this is, as I was filling up the babbitt material in here, it seemed like some of it was leaking under this dummy shaft, and we had took babbitt right and we had put it down in there and tunked it in there really good, hoping that we would prevent any from coming up inside the hollow shaft. And one thing we learned, we just talked about, is we should have welded a plate inside this dummy shaft at the bottom. That way it wouldn't allow any material to come up inside. Really important to soot your dummy shaft so that when it comes time to release, which you'll see later, once this is all cooled, we'll try to press that out of there. Really important to get this up to at least 450 degrees. All this, what that does is take the moisture out of it, because this hot babbitt material going there will splatter. The least bit of moisture, you're going to get burnt. This stuff's going to go everywhere, and anybody around you is going to get splattered. So heat that up really well. You got this centered where you want it, because once that's hardened, if you ain't got it right, you're going to have to melt it out and redo it. And you want to make sure that you clean your babbitt material out with some paraffin wax. Get that, your babbitt's got to be poured right around, I'm guessing around 600 degrees is about what we poured it at. And you put your paraffin wax in there and you stir it, it'll light on fire as you saw. and then you skim that impurities off the top. That way you got nice pure babbitt material in here. You don't want a bunch of chunks of stuff and impurities in there. It just makes it for a bad surface. And I think that's about it. Take your time. Sometimes you have a tendency to rush because you get excited. We do. As you can tell in the video, we're going to leave all the bad stuff in there so you learn from us. We're not going to edit that out. We won't leave that in. We make mistakes just like everybody, and as you will if you try this process. I'm sure you'll make a few of your own. So that's it. We're going to let this cool off to 0 degrees. Well, not 0, but room temperature. And then we're going to try to press that shaft out. We'll take all these nuts and bolts off, and hopefully by sooting that shaft up, that'll allow that to release and push out. So, if you try this, good luck. Okay, it's later in the evening now. We're here. We're going to press that dummy shaft out. Brian's got a block of wood, and that is slowly working its way out. And from what we can tell so far, we have a pretty clean, barren surface in there. We're just going to take our time, work that out of there. That has a taper on that shaft, but it still comes out quite hard. And we're leaving the babbitt behind. Take that out, Brian, so I can show these guys. There you go. As you can see, that piece, that shaft is coming out. It's leaving us a good, nice, smooth finish. Almost a machine finish on that. Alright, we're going to finish driving this out. We'll give you a look what it looks like when it's all said and done. Yes, Byron?
For those who might copy this procedure, probably a couple of thousandths taper would be better than I've got it. It's almost a dead zero from one end to the other. So 2 or 3 thousandths taper in the direction that we're driving it down through would be quite advantageous in this process.
Here we go. We'll get back to you in a minute. Back at it. As you see at the bottom here, we're coming out really nice with that shaft. I think we're on the last few whacks here. Sounds good, don't it? Oh, look at that. We have 1 dummy shaft laying on the floor.
And 2 watching.
And 2 watching. So there we go. Well, we
No
got a couple of other people here watching the process.
No, we're the part of the process.
We're looking downside here. We have an extremely clean babbitt board there. Really happy with that. All right.
Well, good morning. Today I have roughed out 2 beechwood blocks, which will be the contact blocks in the spider for, that's what's being used for the friction drive that's going to hook up to, I got the friction disc. I've got to take and machine the same taper on these blocks. Once I get them bolted into the spider, I'll come back and put this whole thing in the lathe, and I've got to machine the taper in those that will match up over here to the friction disc, and that's going to be welded eventually onto the base plate. So we've got the blocks made. They're roughly 1 3/4 inches by 2 1/4 inches by 5 9/16 in width. That's how we've got those set up right now. I've got to machine elongated slots across here in 2 places that will match up to those holes where the bolts will be coming through and securing those blocks into the spider. So that's what I'm going to be setting up to do next. Alright, now we've outlined the, I can turn the light off here, maybe you can see the, outlined where the holes go on the blocks, and we've set it up in the milling machine, and I first did a pilot hole down through in this location right here, And then I've put in a 4-fluted end mill, and I'm working back and forth across for the elongated slot for where the 3/8 carriage bolt is going to come through and fasten these blocks into the spider. So you can see how this is basically set up. I've got a wooden block underneath the main piece so that the end mill won't cut into my vise when I punch down through. So that's how that basic setup is working. So we'll continue that process and catch you in a little bit. Well, here we are back. I've got the second block machine now. You'll know the difference. Murphy's Law kind of caught me on the first block. You see, I put elongated slots in the block, and it was not necessary because the block, the elongated slot in the spider is all that's required. So when I put the block in place and I'll have the bolt coming through, the adjustment will allow this to come back and forth as needed for increasing the diameter of the piece after it's been machined. So I only needed a round hole for the bolt to come up through in this position instead of the elongated slots that I did in the first piece. It's not going to make an impact on the function of it, but just something that was not necessary to do. So I've used 3/8 carriage bolts. I'm also using a washer, a flat washer with a lock washer and square nuts. The flat washers, I'm putting, there's a dog. The flat washers that are going to go on in this manner, I'm taking a chisel and making a small cut in the OD to raise some metal against the back side that will bite into the wood so that the lock washer will get a bite on the washer and it won't turn during running. So there was a little screw up, but you know, all projects have their learning curve. So we're pretty close to having this assembled, and the next step for this piece is going to be to put it in the lathe and proceed to start turning those blocks to the diameter and taper that will match the friction plate over here, which has a taper in that. It's a 5-degree taper. It's about 10. If we look at the drawing, it's going to be this diameter right here, which is 10 and 29/32 to this sharp point right here at the end, outer edge there. These blocks will pick up on this surface right here, so as it comes in on that taper, it'll get a bite. When the clutch is turning, it will bind up on the wooden blocks and start the crankshaft running. So there's the function of that. Those pieces are going to have to be put onto the assembly and welded on. Those are the last two things to do on that before it'll be able to be assembled on the hammer. And then we got to finish the linkage work on it, and we'll be ready to start running. So we're making progress. All right, catch you a little later. Well, here we are, set up in the lathe. This is the basic setup. I've got a dial indicator up near the chuck, and that's running 2 thousandths or less. And with a wooden block for a center going into the end of the tube on the tailstock end, yeah, I got to make sure that that's running true also, because the thing could be cocked in there. Even though you had 1 thousandths at the headstock end, the back end here, when I first set it up, was running out about 15 thousandths, and I had to scrape the center of the wooden block, and I've got that's running about 3 thousandths now. So we're good to go. Here's our blocks all assembled. Tool holder, we got a boring bar, set up on here. We've got 5-degree taper. I'll be making the cuts with the compound only. So I'm about ready to get started with that. I got to remove the indicators and start turning the wooden blocks. I get my wife to come back here. She'll do a little recording while I'm making the cuts. All right, we'll catch you in a little bit. All right, we've got the spider mounted up. We've got the wooden blocks located. I've got the machine set with a 5-degree taper. We're going to machine the taper in this angle like this, where this will end up fitting into the clutch friction plate. So we'll go ahead and start the machine. I'm cutting here with the compound. Just feeding it in by hand. I'll have to do this several times to get down to the finished diameter. I've got a round nose, high-speed steel tool bit that I'm using to cut here. This wood in these blocks is beech. That's what I was told from the Little Giant people was the material that they used when they were replacing those blocks. So it's cutting real well. Got the tool mounted in a 1-inch boring bar. And right here to start with, I'm taking a 1/16 of an inch depth of cut. I didn't know how much that was going to pound without interrupting cut, so that just about finishes that first pass.
Okay, Byron is going to try the friction plate on the spider gear here and see what kind of a fit we have with the angles on the on those wooden blocks. Boys, that looks like a nice fit right in there.
Look at that right there.
That's what the back end of that clutch is going to look like with the wooden blocks, and as that friction plate has got there, hooks onto the main assembly over there, that'll get pushed into those wooden blocks, causing the main shaft, which would be the way you see the center wood, would be the main shaft on the machine, and that is going to work really nice.
You can see the fit in there. If you can see it.
I'll zoom in right in on that.
Got a nice match on the
nice,
angle.
Nice match on the angle.
And any mismatch that is there, as soon as we start operating the machine, that is going to wear right in and be a perfect match.
Looks very nice.
That is done.
Yay. One more portion done, and we'll get back to you a little bit when we start adding the friction plate to that main drive plate. Here we go. You get a good picture of the spider on the back of the clutch assembly. We have the friction plate, which is up against the blocks of wood, and then the belt drive is on the outside of that plate. Just to give you an idea what it's going to look like. We don't have either plate attached to that main drive plate in the back yet. But just to give you a good idea what it's going to look like, that is what they look like. That looks really good.
Yeah.
And There it is. That's a picture of one. We zoom right in on that. There we go. That right there is what we're trying to build. And once again, there it is right there. I think we're pretty darn close.
What we may want to do is take this outer drive plate and cut some of it away so that it's not as wide as what it is. That'll take a little bit of the weight off it too.
Yep. And there you go.
Take that over there and let them saw it.
Saw it. There we go. We'll get back to you once we get it welded.
Well, here we are today. We've put the friction disc onto the back plate and we've tack welded that in 4 spots at present. I used the spider to locate the friction disc. In setting it on there, the spider dropped down through the bearing, and when it come in contact with the friction disc, it automatically aligned that. So I didn't try to do anything different with setting it up on the rotary table and indicating it in or anything. So now is the process of welding that on. I put a small bevel down here at the bottom of the friction disc down here in this area so that that fillet weld will get a better penetration. I didn't attempt to do 100% penetration. We just got going to put a nice large fillet weld in there, and that'll securely hold that, we're hoping. So the piece is coming together. It's looking pretty good. Yeah, I've added 4 more welds. You'll notice that I'm doing tacks all the way around. I'm working opposite sides all the time, working my way around. I'm taking a break right now, going to minimize putting heat into the part to make sure that we don't get any distortion due to the overheating the metal for welding and warping it. That's a 1-inch plate on the base, but we still could create some warpage with that if we put enough heat into it. So we're going to refrain from that, take some time and work our way around and eventually tie all of those welds together. Well, here we are. We have the friction disc all welded in. We've got we kept the temperature down. Took most of the afternoon to complete it, but you can see there's a whole series of about 1.5 inch welds that I did as I worked my way around it, and it's still got a little temperature in it, but it's a little too hot to touch, but not bad. So I'm hoping that the distortion is very minimal. So we got to clean up the welds, make them look kind of pretty, get rid of the spatter and whatnot on there, and I've got the drive disc that the belts go onto that's going to weld on out here, and that piece has got a lot of rust and stuff on it, and I got to clean that piece up, and then I'll have to line that up on the rotary table to get that concentric to everything else. So far so good. Everything's looking good. 1 piece left to go on it, and it'll be ready to move up to the hammer. And at that point, all we'll have left to do is mount it on the machine, drill a couple of Dutchman screws to lock it in place on the shaft, complete the fabrication of the shift linkage, and we'll be good to go. Right? So far so good. See you later. Well, we're back at it again today. We're welding on the final part, the outer ring, which the belts will drive this unit. I'm doing a series of welds around the periphery to the base plate, making short welds, working equal and opposite as I work my way around, kind of a stitch weld process in order to minimize the distortion. Taking a time break in between some of the passes here and cooling the piece down with a wet rag over the top of it. But things are looking good. We indicated it in this morning to the base, to the main unit. Got it pretty consistent with concentricity. It's running out about 25,000 total, but that's due to warpage in the outer round condition of the outer ring itself. So this is our setup, and this is how it looks in pretty much its final state. Needless to say, we don't have the spider inserted in it at this time. So I've got a hole to drill through the babbitt in this piece for lubrication purposes and reinstall the zert fitting down in the portion underneath here that you can't see right now. But that's going to be about it for the fabrication portion, and next we'll be taking it up to the hammer at Jerry's blacksmith shop where the machine is installed, and at that time we'll assemble it to the shaft, cut the shaft off to length, and install some anti-rotation screws to lock this piece of the spider, that will be lock the spider to the shaft. This piece here, the clutch collar itself, that rotates as the motor runs continuous and then transfers the power to the spider to start the machine functioning through the linkage, which we still have yet to manufacture and install. There's a dog going by. He's been enjoying the morning. Alright, we'll catch you next time. Well, here we are with our completed components. We have the spider, we have the clutch collar with zert fittings, we have a zert fitting in the clutch friction plate. You can see that on the inside. That's for lubrication. We also have a zert fitting here in the end of the spider so that we can get lubricant to two locations with the assembly put together. Alright, this is how it looks at this point. All the components are completed. As we look around at it on the opposite side, we've got the drive plate here that was just welded on. We have the friction plate in here, and you can see the spider here is all assembled. The wooden blocks, the friction blocks that drive the assembly. Okay, those are all machined, and we're ready to take the unit up and assemble it onto the machine shaft and complete the fabrication of the clutch linkage. We'll also have to attach, we're going to take, once it's assembled, we're going to put two screws in the bore, one located here and here, halfway between the spider and the shaft for locking the spider in place on the shaft. Okay, I'll be back in just a second. I'm going to assemble the spider inside the clutch assembly and show you what that looks like. Alright, now we have inserted the spider into the clutch assembly, and that's what it's going to look like when it's on the machine. Alright, so far so good. The project is going along. We're nearly complete. You can see how it looks on the other side now. This attachment of the clutch linkage will fasten onto these rods on the clutch shifting fork that will engage the the friction plate here to the spider once it's all assembled on the hammer. All right. Hope you enjoyed this so far. And we'll see you next time with it setting on the shaft on the machine.
We're cutting the shaft off the length so that we can pin the spider to the main shaft. Cutting off about 6 inches of this. We'll show you what it looks like when we're all done. Alright, here we are. We've got the shaft cut off and we have put the spider on here. As you can see, we've added a few felts here behind the clutch collar to hold the grease in between on the Babbitt Baron. And here we are in the front of this here. You can see where we've cut the shaft off. And Byron's going to point there. We're going to do a Dutchman's drill right on the very edges of those, perpendicular to each other, there and there. And what we'll do is we'll drill in that groove, which will be halfway in the spider and halfway in the main shaft, and we'll tap those, and then we'll put a bolt right in there, and that'll attach that spider to the main shaft. And we're going to hook up the clutch collar next and show you what that's going to look like. And
The clutch shifting fork.
I mean, the clutch shifting fork is what I'm going to show you next, which is down there on the floor underneath that thing right here. This was forged here in the shop. Quite a bit different than the original, but we made it to what we thought would work best for our application. So we'll show you that in a minute. Okay, what we're doing now is we put a Dutchman screw into the main shaft and pinning the spider to the main shaft. And Byron is winding that one screw into place. Once he gets that in there, I'll get a little close of it up for you so you can see. Okay, as you can see, we drill partway into the spider and halfway into the main shaft. Now that's binding the spider to the main shaft, and we'll also, at the very bottom down here, straight across from it, he's showing you right there, we're going to put one more right there, and that'll pin that right to that main shaft, and that'll never move. And we'll put some Loctite on those when it's all said and done. And that'll be that, and that'll be good to go. Alright, I'm going to show you how this this clutch all works. See, the wooden blocks is on there. Now Byron's going to push down the treadle. See how that comes forward? Do it again, Byron. She's sticking a little bit because you got no lube on it. There we go. See how I was pushing forward against the wooden blocks? That grabs that wooden block and causing that main shaft to spin. We'll do a little better clip here in a second to show you how that's really working. Okay, we're going to spin that. Byron's going to spin that. See, right now this machine is in neutral. See how it's spinning free around those wooden blocks? Now as he pushed down on the treadle, see how that grabs and blocks? Now we're spinning the main shaft. And that's what this will do once we get the belts on the outside of that clutch pulley, is once you push down the treadle, it'll push that clutch forward onto the blocks. Now he's released it, and the return spring has kicked it back into neutral. So this is, there it goes again, you push down the treadle. It's working really good. Everything's got to be lubed up, and this will all act a little differently once everything is oiled and lubed up. So there we go, that's our clutch. We spent all this time making the spider. And over here, we're going to show you the clutch fork linkage, which I fabbed right here in the shop. As you can see, it's there once again. Yeah. See how that's moving it forward? It goes all the way down here. We got it turned out a little different than the rest of them. Comes all the way down to the bottom, all the way over to Byron's pushing on the treadle right there, which operates the clutch back and forth. So there you go. We'll next process is get the electrical hooked up and get the belts onto this pulley you see right here, and we'll be giving this a try. He's going to show you where the belt goes right there right now. There's two belts that go around this. They'll set right on that right there, and they'll go down to our motor down here, which has got a double pulley, and we'll do a little adjusting on that motor, get it put into position, and that's what will run that clutch. That'll be spinning all the time. This machine is being operated on. That clutch will be spinning either engaged or in neutral. There we go.